Okay, perfect. So we're going to have Paul, possibly. So yeah, I guess let's start with the other topics. Kiva, is there anything I can do for you for the dashboard integration for OSD creation?
So far, no. I'm still marking up the front end, and after that, maybe I will find something lacking.
Okay. Okay, perfect.
So to recap, this week we discussed about the drive group, and I think the conclusion is we just ignore the drive group currently in the orchestrator backend, and we just start from the US viewpoint, and if users select some devices, we just create a new drive group.
Yeah.
And just submit this drive group to the orchestrator.
Yeah. Right now, DeepC is the only orchestrator that supports non-trivial drive groups.
Yes.
So for the other backends, you have to manually specify the drive path in the drive group.
Yes, for example, in Rook.
Yeah. So I think it makes sense to start with these kind of trivial drive groups and then continue with more complex drive groups afterwards.
Sure. And I think my first step is right now we have inventory device list, and maybe the user just click on the device and create OSD from the device. There is an open pull request for multi-selection in dashboard. So it's possible to create multiple OSD from multiple devices if that PI is merged.
Okay.
So for now, I just maybe start to implement creating OSD from single device.
Yeah, I think that makes sense. Start with the easy stuff. You may run into issue 41746 in the Rook orchestrator.
Yes, I saw this in Rook.
Yeah.
From my side,
just be aware.
From my side, so every disk is available.
Yeah. Or just make sure that the Rook orchestrator sets available to true for every disk, because the availability is not returned by Rook right now.
It say not available for all disks.
No, it's
just like a description in this issue. Yes.
Yeah.
I have the same result, but I have some available disk.
Okay. Yeah, just be aware that there is a bug in the Rook orchestrator.
This should belong to Rook backend or orchestrator.
It's a Rook backend, a Rook orchestrator module, which is buggy right now.
I'm not sure about DeepC. I never tried DeepC.
DeepC is not affected. It's just Rook.
Okay.
Okay. We want to talk about my new completion implementation, Tim.
Yeah. So since your last email pointing out I now understand the problem better than I did before. I don't have any better idea yet for how to do this. And look, I like I think the structure that you have is quite neat. Doing this one, then this one, it sort of makes sense somehow. I think when I was looking at the getting a list of all the hosts in order to pass it to the create OSDs method, I still think that getting the list of hosts should somehow be inside each orchestrator module. Like the caller who wants to create OSDs shouldn't have to go to the orchestrator and say, give me the host and then pass that back in, because that sort of seems...
I've tried to do that.
Maybe you've already handled that. Yeah, I haven't finished reading through all the complete PR yet, so maybe you already took care of that.
One moment. I think the Rook orchestrator. I think the SSH orchestrator is a good good example. We have a look. Yeah, it's here.
Okay, so create OSDs. Oh yeah, okay, it does self.get host. So that remains internal, which is perfect.
Yeah.
Yeah. Yeah, cool. What was some other? There were some other things that changed as part of this. So it removes read completion and write completion,
Yes.
and we just have a completion.
Yes.
Can you remember why there were originally a separate read completion and write completion? Was there a reason? I mean, I know it's John's original thing.
Yeah. So first of all, I think it's the wrong place to differentiate between read and write completions at that level. It's too early in the inheritance hierarchy. It's too early. So we always have to either duplicate code between these completions, or we have to make a kind of a mix in that where you have to depend on the inherent from the mix in for both completions.
Yeah.
Like for example, I've removed the Rook completion mix in. I had somewhere in the code somewhere. The idea is that read completions are finished as soon as we have a result.
Yeah.
And for write completions,
yeah,
it returns to the caller as soon as we have a result, but in addition, the completion can stay alive until the thing is actually done. Like, for example, you can call to Kubernetes and say, yes, I want to make a new OSD. And then as soon as that wish is submitted to Kubernetes, the control flow is going back to the caller, but in the background, the OSDs are still getting created, like Ceph volume is executed and stuff like that. But as soon as we have submitted the configuration change, the completion is basically has a result, even though it's not yet effective.
Yep, got it.
And my change basically changes this to the completion is always complete if we have a result. So there is no differentiation between read completions and write completions. But the progress reference for the progress module stays alive until the OSD is actually there.
Yeah, that makes sense.
So the only thing that stays alive is the progress reference, and the completion itself is long gone at that point in time.
Yeah,
which makes it possibility to have only one kind of completion that's used for everything, and one kind of progress reference that is used for everything. I think it's a better structure.
Yeah, cool. Yeah, I'm happy with one type of completion class. The doing the read and write and doing mix-ins or duplication is messy somehow.
Yeah. Object orientation is cool, but you're sometimes running into issues where you inherent in the wrong place to the wrong thing, and that makes it messy in other places. So, for example, the test completion mix-in was just a thing to some boilerplate, basically. And in the test read completion, I'm inheriting from test completion mix-in, and the write completion, I'm also inheriting from test completion mix-in.
Yeah.
It's just messy at that point.
Yeah.
And have a look at a few lines below. There is a deferred write function.
Right. Make progress. Okay.
And it's basically the same as deferred read, a few lines above, with the exception that there is some kind of progress attached to that completion.
Yeah. Yeah, cool. So then the caller has the completion, and then they can check the progress if they want to see what's going on further.
Yeah. And I want to use the progress reference to lock things for the dashboard. Like, for example, you cannot create any new OSDs as long as there is a progress reference attached to creating OSDs.
Yeah.
Or there is a progress reference which corresponds to creating OSDs, and as long as this progress reference exists, you cannot create any new OSDs or call create OSD.
Yeah.
Why not, Sebastian?
Yeah.
I asked because maybe if you are using drive groups, probably you can select a big group of OSDs in order to do the operation, and it's a big operation that is going to take a lot of time. But maybe that it's possible that the user wants to create just 2-3 different OSDs using three commands, okay? So if you get the return of the command immediately and the operation is being executed in background, this is possible, okay? And why we are going to block the possibility to execute several create OSDs operations at the same time?
Because inside of Rook, the loop only processes one event at a time. So as long as the OSD creation is in flight, I don't know at which point that loop is going to break, but in general, you can only have one modification of the CR at a time in Rook. And the other changes are then queued. So if one operation takes longer, then the rest are just queued until the first one is complete. That's why, I want to introduce some kind of logging for the dashboard.
But well, in this case, this is a limitation of Rook.
Yeah.
Why we should move the limitation to the orchestrator?
Because the orchestrator is the only place where we can introduce some kind of locking over all orchestrators. Like, for example, in Ansible, I think if one operation on one host is in flight, like, for example, we are creating OSDs on one host, then it does not make sense to create another set of OSDs on that specific host. And in the dashboard, you have no immediate feedback that an OSD operation is in flight. So the user is really tempted to create another set of OSDs on the same host if the first operation is still in flight. And that's from user experience some kind of bad.
Yes. Well, I think that in any case, I think that to include limitations in the parallelization in the orchestrator is not a good idea. I think that is something that depends from the backend, only from the backend.
My idea was to just include that for the dashboard so that the dashboard knows that an operation is in flight, but do not physically lock these operations in the orchestrator itself, just to make that kind of locking available for the dashboard so the dashboard can block changes.
Okay.
And if we need different
block changes, does that mean that?
Go on, Paul.
I think we've arrived at the same point there, Tim, because I think what I was going to say was if you've got an OSD operation and then you want to add an RGW or you want to change a MON, those are simultaneous tasks we could potentially schedule, right?
Yeah.
So in this new proposed sort of situation, would that be blocking so that any change to the system is going to be effectively through a single funnel? Yeah. So it would block until the progress is out of the way for the different types of operations that we could do within the dashboard, within the GUI. Is that what we're saying?
So for Rook, for example, you cannot create two completely different Radas gateway zones simultaneously. They need to be done queued basically, because the operation of adding a new zone is basically queued if there is another operation currently running. So for Rook, I would make sure that only one RTW operation is running simultaneously.
Right. So maybe the question really is that, and I think this comes back to Wan Mi's point, that we've got limitations of the way in which Rook has to manage things and effectively single threads changes to the CR.
Yeah.
That's pushing back into the dashboard and how the dashboard works.
Yeah.
So is that acceptable? Because that's a model that you're going to take forward for DeepSea. It's a model that you're going to take forward for Ansible. Is that the goal?
I don't know yet how we can structure that in a way that is also acceptable for the other orchestrators. I'm not there yet.
Okay.
So right now the pull request that I'm having open in draft mode only it provides the possibility to include some kind of locking in the future.
Yeah.
But how that locking is actually implemented is
Yeah.
not yet really specified.
Yeah. I suspect that different orchestrators are going to have different granularity of what needs to be locked and what doesn't.
Yeah.
Yeah.
And I think we need to include these kind of different mechanisms into the orchestrator locking mechanism. But I don't know how yet.
Okay, we can investigate that.
Yeah. Is that okay for you, Paul?
I'm always happy, mate.
Okay. Yeah, let's conclude that topic.
Yeah,
if
cool.
there is nothing else. Okay. Paul, Kubernetes events.
Yes.
So there is a traceback in the logs found by Kiefer. You've seen the tracker issue, I think.
I vaguely remember seeing it first thing this morning, but I haven't got to it yet because of other things that are higher up on my to-do list, unfortunately.
Yeah. If we...
So that was trying to run the module outside of outside of Rook, right? So Rook hadn't set the environment variables.
Yeah.
So we definitely need to, I agree, close that gap. It shouldn't go there in that scenario.
It's kind of an edge case because in a development environment, we are always including all modules.
I mean, one of the things I was thinking of doing after I saw it was that if we push it into the can run method and say, look, are these environment variables there or not? And if they're not there, then we can't run. Would that be all right? Would that work for you guys?
Yeah.
Cool. I'll pick that up.
Awesome. So is it okay for you if we postpone the Nautilus backport until we have a fix for that traceback? Or is it too late for your downstream release?
No, I think we're waiting anyway.
Now.
Yeah, no, we're waiting anyway for other stuff. So I can put a patch to master and change the backport release, the backport request to include the other commit too.
Okay. Because I know that you already had your feature freeze for downstream, at least for Rook.
Yeah, I don't think we're at feature freeze for Ceph just yet.
Okay. Okay.
Yeah.
Perfect. Okay. Perfect. Do we have anything else for today?
Not from me.
Did
Awesome.
you guys? Sorry, did you guys quantify the performance issues you were seeing with Rook when you're doing like inventory lists and that kind of stuff? You were saying that it was a bit slow.
Kiefer?
For me, I tested in virtual machine, so it should be slow, but I don't quantify it yet.
Okay.
But with the introduction of the event listener, the performance issues basically went away, right? More or less. Okay. So for every call in the dashboard, we made a full fetch of the inventory of all hosts in Kubernetes, and it was kind of slow.
Ouch.
Yes.
Yeah.
Right now, dashboard does not support paging yet.
And yeah, pagination. We might need to add pagination to the dashboard if things are really too slow. But yeah, let's see if we come to that point at any in the future.
Cool. Thanks.
Okay. Enjoy your evening, Paul, and Kiefer and Tim, and yeah, have a nice day, Jean-Miguel.
Have a nice day.
Hey, thanks, guys.
Thanks, guys.
Bye.
Bye.
Bye.